Good evening and thank you all for joining us today. Welcome to Microsoft Reactor livestream event. My name is Rashmita and I'm the event planner for Bangalore Reactor. Session will be approximately 50 to 60 minutes with 10 minutes of Q&A. So please feel free to drop your questions in the chat box. We will try and answer as many as possible. I have already shared the event check-in link with the event ID in the Q&A section. So please feel free to do event check-in and this will give you access to additional resources and information about event that we are running on Reactor, which are around similar topics to today's session. Also, you will be able to access related links to today's session. I will also share a link to our feedback survey, so if you could fill that out with the same event code, that would be great. Also, this will be uploaded straight to our YouTube channel. I would now like to introduce Abhishek, our speaker for today's session. Abhishek is a senior cloud advocate at Microsoft, where he helps developers be successful with Azure platform. His key focus areas include database, Kafka, and cloud-native technologies. Abhishek loves technical writing and sharing knowledge through blogs and books. But for now, I will hand over to Abhishek to begin the session. Over to you, Abhishek.
Just wanted to make sure I unmute myself. Appreciate it. Thanks, Rashmita. Thanks for having me. Yeah, awesome. So I guess I don't need to introduce myself. Rashmita has done it already. But I think what was not covered is, or maybe I didn't add it as a part, is the fact that I do have a long Java background, but over the past few years, I've had this growing interest and love of Golang, and that's what I'm going to talk about today in the context of Azure, right? And my Twitter handle is right here in case you want to connect and chat. So feel free to do that. And that's me, in case you didn't get it already. All right, so what do I have in store for you today? I will give you an overview of Go in general before diving into some of the Azure specific areas. And I do have a lot of, I think about 4 to 5 demos planned, so wish me luck. I'll take questions at the end if that's okay with you. Yeah, and just a quick, just to set the context, right? This is not going to be like, it's very hard for me to cover within the space of, say, 40 to 60 minutes, the entire breadth of Go, or for that matter, even Azure, right? So this is more to make you aware of what's available, what's possible. And like I said, I do have a bunch of demos, so hopefully you'll find it interesting and be able to relate it from a practical point of view as well, right? So hope it's all going to make sense at the end of the day. And if there is one takeaway from this entire talk, please make sure of this link. If you can, I don't know, Rashmita, if you can do that, just if you can, copy paste this in the chat window, that will be super helpful. aka.ms/azgophers, because this is where you'll find the slides. They're still there. If you go here right now, you should be able to find them. And then all the links, the resources, etc., are there in the slides. So including the GitHub repo for all the demos, etc. Right. So make sure that you make note of this, and hopefully, Rashmita, if you have been able to drop it in the comment, will be super helpful. Thank you. All right, awesome. Let's dive in. So what is Go? It's also known as Golang. I mean, it's actually easier to find it with the term Golang as opposed to Go. So it is an programming language, of course. It's open source, built and developed initially by folks at Google. And this was released, open source back in 2009, I believe. The official website here is golang.org for you to dive in, get started, download it. Yeah, so that's your place to go. What does a typical Go program look like? So you write your Go programs in files called, with the extension .go. Typically your entry point is named main.go. You have a main function right here, as you can see, and a main package as well. You import packages using the syntax import and the name of the package. Font is a package from the standard library, and you typically write functions with this signature, right? So func, name of the function, and then the parameters, right? In this case, we are doing something super simple. So we have a function called hello. We are calling it from main. And in order to run this program, I can simply use go run. and then the file which I want to run. In this case, it's called main.go. You can also build your program into an executable. Haven't covered it here, but you would use go build for that. So yeah, this is what typically a Go program looks like. Very simple hello world looks like. In terms of some of the good and the not so good parts about Go, and these are my personal picks. You will see different inputs or variations of this from the community or other developers if you speak to them about Go. But for me, what matters or what I really love about Go is the fact that first things first, it is simple. Like literally it is simple, right? And I don't want to compare it with any other programming languages. I don't find that fair. But if any one of you has tried to learn Rust, and by the way, I love Rust, not a problem at all there, but just compare it with some other programming languages, you will find that the learning curve for Go is really simple. And the programming language itself, right, inherently it's built around the concept of simplicity, something which I really appreciate. It has a very rich and solid standard library, so you can use that as a reference in terms of if you want to learn about how to write idiomatic Go code. And of course, it gives you and it helps you write day-to-day code with much more simplicity, in the sense that it has solid HTTP support, support for JSON, support for encryption, and bunch of other stuff which you would expect from a good standard library of a programming language. More often than not, there is just one way to achieve something in Go. They're not, I mean, you can be smart. I'm not saying that you cannot be smart with Go, but more often than not, there's just one way of achieving something and writing your program. And that is, again, it ties back into that concept of simplicity, right? Makes it simple. And this concept of hard to change, and this will have mixed opinions. Go typically has a very, it tends to be very choosy about what to accept into the language in terms of changes, in terms of say updates or features, and so on and so forth. So there is less things to worry about, less fluff. It can make things boring, right? And for me, it's good. And you'll even find talks that, hey, Go is boring. Just search for it in Google. Just Google it and you'll find that, and that people appreciate this fact a lot, that Go is boring in general. So that's a good thing in my opinion. Yes, there are things which I do not like about Go, at least not so much. One of them is dependency management. And trust me, it has improved a lot since I started, since at least, 4 or 5 years back. Now Go modules are much more solid. They have evolved, they have matured a lot. But before that, things were a little, fragmented or scattered all over. And even Go modules, there are still projects and the community is still sort of embracing Go modules in general. So as a newcomer, you may find that challenging, but it's improving, right? That's a good thing. And another fact is, for me, that there is no standard way to structure your applications in Go. Again, you might be developing, for example, a web API, right? Yes, there are sort of accepted best practices, but I haven't, found standards as such. So those are things which can, sort of trouble you if you are a newcomer, but you'll figure it out. So I thought I should mention them as well, not just the good parts. Typically, what is Go used for? It's very dominant in the areas of cloud and networking services. If you're building REST APIs, over HTTP, or you're using gRPC, Go is already pretty solid in that area. It has very good support there. Even in the area of DevOps, SRE, which is site reliability engineering, infrastructure as code products and services, you'll find Go pretty much dominating that area right now. And one of my personal favorites is CLI apps. So Go has very good, it doesn't have like inbuilt support. Yes, standard library supports some of those constructs, but it has very good libraries in the external ecosystem, third-party libraries, which are which help you build very good CLI applications in Go. From a cloud perspective, some of the good parts of Go include it has very low resource overhead. So that directly contributes to the great performance and things like that. And going back to the standard library, because it has very good concurrency support, HTTP, there's support for databases, sort of at least, you know, sort of the framework is built right into the standard library. So that's going to really help you when you build, those cloud applications. And the fact that you can compile a Go program into static binaries for the operating system of your choice. So I'm on a Mac, I can build that for my Mac. If you're on Linux, you can just pass arguments or parameters. You can just tune the Go build system for your particular operating system, and the end result will be just a static binary. That's pretty much all you need to run your Go program, and that matters a lot in the cloud, right? From an infrastructure perspective, and just from an ease of deployment standpoint. And if you look at this comment from the link I've highlighted here, if you're aware of Cloud Native Computing Foundation, the CNCF, they have a huge number. I mean, pretty much all the projects are in Go, I think 75 to 80%. And Rust is sort of coming into the foray as well. So yeah, Go and Rust are very common in some of the Cloud Native projects, which are built under the CNCF umbrella. If you want to go, get started, just to go to golang.org, install Go, use VS Code or any other IDE for that matter on your laptop. Start off with Tour of Go. I'll highly recommend that, and then dive into effective Go. This should give you a good baseline to start off with, and then you can play around, build some sample demo programs, and get going. In terms of some of the references, I would highly recommend checking out some of these. Of course, there are lots of other things or other content about Go, but I would recommend checking out anything from Rob Pike, who happens to be the co-creator of Go, the talk called Why of Go by Carmenando, things from Samir Ajmani, who I think he's the engineering manager at Google, who works with Go. And I had a lot of fun, watching the Just for Funk videos from Francis Campoy. Teaches you a lot about Go, right from some of the basic stuff to advanced things. So yeah, I would highly recommend this material if you want to, if you have crossed the initial few things and you're looking to dig in more. If I haven't managed to convince you, I mean, I do want to just highlight the fact again that there are a lot of companies already using Go, including Microsoft, right, for various things. And some of the projects which you might be using, and in case you didn't already know, things like Docker, Kubernetes, Vitess, Prometheus, and GoHugo.io. I have my blog hosted using GoHugo. And it's the fact that they are written in Go talks a lot about the stability and the solidity of this language, right? So I just thought I should call it out. Hopefully that should be of value to you. Okay, now let's move on to like I said, the Azure point of view, the Azure perspective about Go. So the first things first, I do want to talk about the fact that there is a first-class Go SDK for Azure. It's called the Azure Go SDK. It is open source, available on GitHub, and you can use these Go packages within the Go SDK for managing almost all of the Azure services, I believe, right? So things like, you can create virtual machines, attach, create network components, attach a disk. You can create database accounts, for example, Azure Cosmos DB. You can create, key vaults to secure your credentials, so on and so forth. Like I said, pretty much any Azure service you can think of, you have a way of, managing it using Go, right? And an important distinction for you to understand is managing versus using, right? So when I talk about managing, it is really a control plane operation, right? So to set up the service and so on and so forth, right? To provision a service instance for that matter, or to update it, or to delete it, right? So that is from a management perspective. And then using the service, it's a data plane operation, right? So it's important to understand that distinction. And in addition to some of the core Go SDK services, there is another package which is highlighted here, for some of these specific services, and I'll talk about them. The data plane aspects are within a separate set of packages which are specific for that Azure service. So I'll highlight them in a moment. So I thought I'll call them out here as well. In terms of cloud native services, I will cover them in a dedicated section. So I'm not going to cover them like right now. I'll not talk about them. But yes, Go in the context of platform as a service, containers, and Kubernetes is also very relevant in the Azure ecosystem as well. If I work a lot with databases, so it's natural that I cover them both from a relational and NoSQL perspective, right? So Azure has a bunch of relational database services: MySQL, Postgres, Azure SQL database, and if you want to work, with these databases using the Go programming languages, you really don't need anything special. Like I said, the standard library already has SQL, sort of the framework built in for interacting with SQL databases, and then you use particular drivers, right? For example, with Postgres, you have lib/pq and pgx, and I think there are a bunch of other drivers, right? Same applies to MySQL. The MySQL driver is extremely battle tested. I think it is. I don't think. I mean, it is used within GitHub as well. And I added a link to some interesting blog post by the GitHub team in terms of how they found out bugs within this Go driver for MySQL, how they fixed it, and so on and so forth. If you're interested, it's pretty advanced, but you should find it interesting nonetheless in terms of trying to figure out the context and the real world use of Go and MySQL within GitHub. And yes, there is a Go driver for SQL Server as well. I've left a link below here in case you're interested in trying that out. Like I said, NoSQL along with relational. My favorite database is Redis. So in case you don't know it already, like I'm wearing this Redis shirt, I hope that attests something at least. So I love Redis, I love Go, and if you combine them, they form a very fast, nimble, and lightweight way of building applications, right? So Redis is the Swiss Army knife of it can be used for multiple purposes, from doing simple pub sub to caching, session store. It's of course we can have a separate Redis talk altogether, so I'm not going to dive in. But what I wanted to highlight is you can use some of the popular Go Redis SDKs. I have highlighted Go Redis because I personally use this a lot. I think there is another one. I forgot the name. If you search for highly used Go Redis packages, you should be able to find them. But I use Go Redis a lot with Redis in general, as well as with Azure Cache for Redis, which is a managed Redis offering on Azure. So yeah, it's pretty rock solid. I haven't found a lot of issues as such. So feel free to try it out. Yeah, works pretty well. So there is first-class support built in there. I want to drop in a word for Cosmos DB as well, which, in case you don't know, it's a multi-model database which supports lots of APIs, including open source proxy APIs for Cassandra, MongoDB, as well as Graph. There is a core API which is very SQL oriented. But yeah, I want to highlight the open source components as well. And like I said, I mean, if you already know that there are official Go drivers for MongoDB and a very good community supported driver for Cassandra as well. So I do want to shout out the support for MongoDB Go driver. It is very solid. MongoDB is putting a lot of effort, engineering efforts behind the official Go driver, and it works with Azure Cosmos DB as well. So yeah, feel free to try it out. I have left links here for specific quick starts for Cassandra, MongoDB. They are part of the Azure documentation and a bunch of examples which I have written, some demo applications in case you are interested in trying out. So for instance, you want to try out how to use change streams in MongoDB with the Go driver. There is an example for that. Slightly advanced use cases, but still, if you're interested. And if you want to figure out how do I use or make use of rate limiting for Cassandra API and Cosmos DB, there is something for that as well. Like I said, they're slightly advanced, but if you want to try them out, feel free to do that. Works pretty well. Like I said, pretty solid support overall. I work a little bit with a bunch of big data services as well. One of them happens to be Azure Data Explorer, also known as Custo. It's a big data analytics product. It has a bunch of parts, including ingestion, and it has a very popular query language as well. It's called KQL, Custo Query Language. But the main thing, or rather the important thing, is that it has a first-class Go SDK, right? So they are separated into components such as one is for management and the other one is for data plane operations. Like if you want to execute KQL queries, if you want to query Azure Data Explorer using their Go SDK, yes, you can do that. And I've, like always, I've left a link here in case you're interested in trying it out. And last but not the least, not everything has to be, RPC direct, RPC over JSON or over HTTP. But so there are a lot of messaging services for asynchronous communication within the Azure ecosystem. Event Hubs is quite popular, and there is Service Bus and Event Grid as well. So there are first-class Go SDK, not for Event Grid, it is there for Service Bus and Event Hubs. So feel free to check them out. I personally have not used Service Bus a lot. I use Event Hubs very commonly using the Java as well as the Go SDK. So pretty rock solid. Feel free to try it out, give feedback, go enter issues on the GitHub issue tracker. So you're welcome to do that. I thought I should definitely give a shout out for that as well. And not to forget, components like CI/CD and DevOps, right? So there's good support for if you want to include or run your within your GitHub action workflows. There is support for Go. Azure DevOps also supports Go, and Pulumi, which is a very interesting project. I don't know if you've heard of it, but it's an infrastructure as a code project which has very good support for Go as well. I'm going to actually demo that, so let's wait for that. And from an IDE perspective, yes, there's IntelliJ as well, which has very good Go support, and of course VS Code as well, right? So it should, probably if you're starting out, starting off with Go with VS Code is probably a good idea. Okay, that's that. I'll dive into some of the cloud native sections now. So in terms of the ecosystem, right? Cloud native, the word it's heavily overloaded, and there's a lot of components and services which are associated with that word. But for today, let's just confine ourselves to these sort of areas. One is IaaS, infrastructure as a service, PaaS or CaaS, which is platform as a service, or containers as a service, Kubernetes. Nothing is ever complete without mentioning Kubernetes, right? And functions as a service, which falls into the serverless ecosystem. IaaS, of course, you can lift and shift your Go apps which you're running, say, on-premise right now to Azure VMs, right? But yeah, sure, you could do that. Not super interesting, at least for me personally. Of course, it's from a use case perspective, it is pretty widespread. Customers do that all the time. But I'll leave that as a pointer, as a homework for you to explore, and I'll move on to some of the other interesting things, at least for me, right? And hopefully for you as well, for those of you who are who want to understand the cloud native aspects. So one of the platform PaaS components is Azure App Service. So it's this completely managed platform, as you would expect with any cloud service, which you can use to build APIs, these MBAS, mobile application backends, web apps, right? It supports a lot of languages out of the box, default, Java, Python, Node, .NET. It can do all the good stuff, right? Scale for you, do CI/CD, etc., available across Windows and Linux. But of course, I'm talking about these because it also supports Docker containers, right? And there is think of this as a separate flavor within Azure App Service. It's called Web App for Containers, right? So it can, so when it comes to your Go code, right, it may not be supported out of the box. When I say out of the box, I mean from a programming language support perspective. But you can always package your Go code as containers. I guess you're probably already doing that. Because it makes a lot of sense. And once you package them as Go containers, you can run them within a fully managed platform like Azure App Service. And I just wanted to throw in this example here, which I had built some time back, if I want to check it out. And this was inspired from an existing application which I ported over to Go. So it uses Azure Cognitive Services with some text translation capability. So it has a front end, which is not good. I'm not a front end developer, but the backend is Go, and it does stuff, right? So I thought it might be a good example for you to dive in and try things out, deploy this translation service on web app for containers, and take it from there and give us feedback, right? So yeah, feel free to check that out. Moving on, towards that spectrum, like I was saying, from PaaS to CaaS, which is containers as a service. The first class component or a service on Azure is Azure Container Instances. It is, in my opinion, the fastest and simplest way to run your Docker container within Azure, right? Again, fully managed. And the interesting part about ACI or Azure Container Instances is it's per second billing, right? So you literally pay for what you use, right? Like I said, very simple. You can use the Azure CLI, just a simple command, az container create. You point to one of your existing Docker images on, say, a Docker hub or within Azure Container Registry in a secure way, and just be up and running in a matter of few, I would say, seconds on the cloud. In terms of use cases, like I said, because it is, it has this notion of per second billing, so it lends very well to event-driven applications. Think about integrating container instances with logic apps, running that as as an infrastructure for your build jobs or for your batch processes, right? And I'll give you a demo as well for that. And one of the advanced features is using it in conjunction with Azure Kubernetes service, a Kubernetes service. I'll give you a demo for that as well, so I'll not dive in right now. So that's a pretty advanced scenario, but something to keep in mind because it, again, like I said, it works very well with the per second billing and the serverless nature of Azure Container Instances. Another interesting aspect and of using ACI is the fact that it is integrated with Docker Desktop. It is relatively, I wouldn't say very new, newish in terms of its integration. So what you can do is use native Docker commands, which you are used to right now, like Docker run and things like that, and use it to deploy directly to ACI. So you're not forced to use, say, Azure CLI. Of course, you can do that. You'll get a very good experience. But if you want to at least do dev test using the Docker CLI, you are welcome to do that. And I'll demo this actually. So I'll not cover this in a lot of detail. So TLDR is that you can simply use Docker run, use this integration, and boom, you'll have containers running in ACI. As simple as that, right from your local machine. But as with every thing, it's not perfect, right? It is not, for example, one of the big drawbacks is it is very fast and everything, but it's not to be used for complex orchestration. It doesn't have auto scaling. You can't do load balancing, at least out of the box. You can work your way around it, and some of the other things, right? So of course, ACI has its pros and its cons. And that is where things like Azure Kubernetes services come in, because it's a full-blown container orchestration platform, right? So this slide is I'm not going to spend a lot of time here, but just to give you an idea in terms of what Azure or any other providers, not just Azure, right? If you go for a cloud provider, giving you managed Kubernetes, so it's up to them, up to the cloud provider to do a lot of the heavy lifting to provide the managed Kubernetes experience, right? In terms of the control plane and some of the other manageability aspects, right? And just like you would for Kubernetes, one of the it has a lot of use cases, but microservices development is a heavy one, right? So, for example, you could have your suite of Go microservices on AKS front-ended with Ingress. You have your CI/CD setup with, say, Helm or Azure pipelines, and of course your microservices can talk to databases on Azure, and sort of round off the entire story with keyboard and some of the other monitoring services and so on and so forth, right? So nothing new here. To be very frank with you, it's not just applicable for Golang. You can do that with any service, but of course it makes sense in the context of Go as well, because it lends itself very, very heavily or very well with containerization aspects and plays very well along with Docker and related technologies. Like I said, I will talk about this in detail in a while, so I will leave that up until then. But a quick, if I were to summarize the slide, where hey, you have these applications running on AKS, but you can scale out using a technology called virtual node. You can scale out these workloads to ACI, where you have you can enjoy the benefits of the serverless per second billing model. and it's very seamless. And like I said, I'll demo that for you in a while. Moving on to Azure Functions, we move on to the Spectrum, which again, this is another serverless compute category. So of course, it has a lot of servers behind the scenes. The name is serverless. But what you don't need to do is think about managing and upgrading or worrying about those servers. They are abstracted from you, the user, completely, right? And the thing about the USP of serverless technology, or FAS, functions as a service in general, is the scalability on demand, right? So it's very elastic in nature. So it can scale out if depending upon your workloads, and it can shrink back in, right? So it's cost efficient as well, right? And pay for use. So you pay only for what you are using right now. So high workload, scale out. The workload goes away, you scale down to zero, ideally, right? So you save money there. Common use cases, I think, if anyone who has worked on FAS or even heard of it, right? One of the sort of hello world of serverless technology in FAS is, hey, you drop in a file into a container like, say, S3 or Azure blob storage, right? And a serverless function picks it up, does something, say maybe convert into PDF, drops it into another blob storage, right? So that's one of real-time file processing is a common use case. Stream processing, SaaS applications. So the last one is actually a demo which I'll demonstrate to you, which I'll showcase. So just wait around for that pretty soon. Yeah. So those are the common use cases for servers in general. But the good news is that, and I wanted to cover it, that the fact that you can use something called custom handlers, which I believe was released last year, somewhere in November or December, if I remember correctly. So you can use Go along with Azure Functions. It has very good support there. And how does it really work? So there are first-class languages which are supported by Azure Functions like Java, .NET, Python. Go is not supported as a first-class language, or Rust for that matter, right? But using something called custom handlers, you can actually run your Go apps on Azure Functions. So the idea here is to have a web server, which you have within your code, and the functions host, Azure Functions host, actually interacts with this web server component. So it sends you the request, your function does its thing, sends the response payload. It's all handled by the functions host. All the triggers, the bindings, which are supported with Azure Functions now, are supported with custom handlers as well. There's no difference there, right? So all in all, this is just a gist of how custom handlers work within Azure Functions. But of course, you should check out the documentation if you want to dive in deeper. With that said, we have, I guess, about 20-25 minutes for demo. So I'll try to dive in real quick here. All right, cool. So first demo is going to be, I'll give you a quick introduction, give you an idea of how to, sort of with a Hello World program as to how you can use Go with Azure Functions. And then we'll take it from there. I'll show you a Slack application, which uses a Go backend, hosted on Azure Functions. I'll show you some infrastructure as a code using Pulumi and Go, and a bunch of other demos, right? So without further ado, let me dive in. And here I am here in my VS Code. And like I said, very quick hello world, for you. For those who have worked with Azure Functions, this structure should look very familiar, right? So you have, a very simple, Go application. The structure is the same, right? From a Go perspective, you may not have worked with it, but if I show you this Go program, right? This is a very, like I said, you have a web server here, which is listening at this particular endpoint. And what it's going to do is, if I invoke, say, a HTTP GET request, it's going to respond, right? Very simple, like application, nothing very special, but let's go and at least deploy this locally, right? So this is what I'm going to do right now. I'll drop into my shell here. And first of all, I'll go build this, Go application of mine. Wait, hold on. Let me go into this particular directory here. Yeah. And if I build this Go application, Go build, and this is -Go, it'll output a binary called Go hello. And I can use the Azure Functions tool here right? I need to update it. I'll do it, after this demo probably. Func start comes from the Azure Functions core tools. And if you see, I am right now, excuse me, sorry about that. I'm running this Go application locally as a simple endpoint here. So if I were to try and access this, I will be able to do this using simple curl program, right? So yeah, you see I'm getting a JSON document back here. This is right from the program. So what did I just do? I just deployed a Go application as a serverless function locally on my desktop. Sure, if you wanted to deploy this to Azure, you can do that using the same, Azure Functions, core tools, CLI program. I am not going to do that right now, but you can use this, Func Azure function app, name of your function app, and boom, it will be deployed to Azure Functions. I will show you some other functions which I've already deployed, but I thought I'll just show you a hello world for you to just warm up to the game, right? And check out some other demos, right? So very simple, hello world, Go on Azure Functions running locally on my desktop. Okay, cool. Let me show you another demo. Okay, so I'm assuming those who use Slack have used this this command called Jiffy, right? It's very cool. I use it all the time. So if I use /Jiffy, it's called a slash command. And hey, I say, hey Jiffy cat. So it'll give me a bunch of options, from cat gifs, right? And I can choose one of them and send them to my colleagues and friends, right? Sure, I can do that. But for demonstration purposes, I built a similar program called Funky. Func stands for function, right? And if I do the same thing, say with Funky, what it does is right now go out, reach out to the Jiffy API. So there is a first-class REST API for Jiffy, and it returns this, a GIF, right? And funky GIF, funky cat, dog, whatever you want to. So this is working in real time right now. And the backend is all deployed using Go on Azure Functions, right? So if I were to go back real quick here, just to show you how this is working right now. So if you see here, I have like a webhook configured, or rather a slash command configured within Slack. And I invoked it using the Slack workspace, which you just saw, using the /funky command, which I've deployed. And this in turn reaches out to Azure Functions, which in turn reaches out to the Jiffy API in real time. And then it returns back to the the Slack workspace to the user, which is nothing but this GIF. Okay. So let me go to Slack and show you how it is all configured. It should give you a relatively good idea, right? So if I were to go here, and if you look at this function called Funky, so this is slash command configuration. If I were to edit it, it should open up. Hopefully, yeah. So this is the URL which I've configured, and this is nothing but a function which I've deployed in Azure right now. So if I were to hop over to my Azure portal and open this function app, it's called Funky app, and go to my list of functions right here and open this, I should be able to show you this Azure function right here. So this is the one which I've configured within Slack right now. So you see this execution count. I just invoked it using Slack, right? So that's that. Very simple application. But hopefully it gives you a good idea, how to use it, how to use Go and Azure Functions in the context of a real world application. I can go through the code, but it's all available, right? I mean, there's no point, walking through the code like right now. It's a main, it's a web server at the end of the day, does a lot of things, interacting with the Jiffy API, so on and so forth. So there is a link here, right? You can go to this app, blog post of mine and go check out the entire thing, run it yourself. So I'm not going to waste time right now with that. Moving on. Quick sip of water. And so you saw this this Slack backend application in the context of Azure Functions, right? But I could use something else, right? At the end of the day, all Slack cares about is an HTTP endpoint where all the business logic is available to it, right? So I can use Azure Functions or, for example, App Service if my use case so demands, right? And in this demo, what I'm going to show you is, sure, I use an app service, but how do I really stitched together, right? How do I bring it up? How do I, from an infrastructure perspective, how it all works? So I'm going to use something called Pulumi. Again, it is not super new, but I'm maybe it's new to you. So I thought I'll throw in a word here. So it's an open source, IaaC infrastructure as a code platform. Has support for pretty much all the major cloud providers, including Azure, and it has a bunch of SDKs. So essentially, you can write your infrastructure in the programming language of your choice, which is Go in this case, right? For me. Go check out this project. It's pretty cool. I'm not an expert at this, but I've started using it of late, and I really love this. And the demo, which I'm going to show you, and all the code is available in this GitHub repo, which I've pointed here, right? So without further ado, let me dive into VS Code again. Let me close all of this, enter into this section right here, and my cheat sheet. Okay, so leave all this. All this is available in a GitHub repo anyway. So what am I going to do here? Okay, so I'm going to use the Pulumi API. The Pulumi CLI here to sort of spin up the entire infrastructure. I have already done these things. So I've configured Pulumi CLI to be able to use some of the secure credentials for the Jiffy API key and the Slack secret. So everything is encapsulated here in this particular YAML file, which Pulumi is going to use at the end of the day, right? So I have my configuration, I have my credentials configured here, and all I need to do now is something called Pulumi up, and the entire magic is going to take place, right? Hopefully. So Pulumi up, and now what it's going to do is it's going to ask me, hey, you want to choose a stack? I have a stack created, so don't worry about the terminology right now. It's called stack organizations. You can always go to the Pulumi documentation and check it out, but it's going to figure things out. What is it figuring out right now? So it is going through my code here, right? This Go file essentially, and it has figured out that, hey, it has gone to my Azure portal internally using the Azure SDK, behind the scenes, and it has figured out using this code that, hey, these are the resources, Azure resources, which this code wants to create ultimately, and it is asking for my consent. I'm going to hit yes, and it's going to go ahead and do its thing while we wait, and I can go through the code real quick here, right? So the code is very, very simple. This uses the Pulumi Go SDK, like I said, and underneath the hood, the Pulumi Go SDK actually uses Azure Go SDK, right? For, of course, the Azure provider, or to work with Azure resources. So if I scroll down, I'm going to show you the code real quick. Nothing, even if you're not a Go developer, it's very, very obvious, right? So I'm just using a bunch of APIs to spin up a new resource group within Azure. Once that resource group is created, I'm using it to create something called a new app service plan, which in this case is, hey, I'm just using a basic SKU here, B1 plan within Azure App Service. And finally, I have the plan created. I can create a new app service, a new web app, okay, within Azure using this particular Docker container. Now, the application which I have, the application which I just showed you some time back, the Go application, is encapsulated as a Docker image. Mind you, this is the same application which I deployed to Azure Functions. It's the same code. I just deployed that or packaged that as a Docker container, referenced it here, and now the Pulumi is going to do all the magic of deploying that Docker container from Docker Hub into Azure Web App Service, right? Azure App Service for, well, I get the naming wrong, web app for containers, right? It's going to deploy it as a container into Azure App Service. It's going to simply do that, and it will automatically also configure app service with the Jiffy API key and the Slack credentials, so on and so forth. So everything is going to be ready for you to use. So hopefully it is already ready. Okay, it is. So it has given us this endpoint, which I will go and configure within Slack. But before I do it, let me go and check within Azure itself, right, as to what resources have been created. So if I just copy paste this name and go back to Azure here, go back to home, and within resource groups, if I check for this resource group, yes. So if you see this resource group, and this has been sort of appended with a random sort of identifier here on purpose, right? This is not a mistake as such. So if you see, this is the resource group, and this has the app service plan as well as the Azure App Service, the backend which I'm going to use. Okay, and you should see the endpoint here as well come up real quick, right? So this is the URL, the URL endpoint. So I'm going to go back here and copy paste this, okay, and configure it within Slack. Okay, so I'm going to edit this right now. Fingers crossed. Hopefully everything works. Save this. So essentially what I've done is just switched. I'm just telling Slack, hey, use this backend instead of the Azure Functions backend, right? And if I go back to Slack right now and try to invoke it once again, hopefully this should work. It works fine. Now if I were to try and prove this to you, so if I go here, scroll down a little bit, so it's one of the very cool features is having access to the live log streaming. So streaming logs of your containerized application. So you should be able to see it right here, hopefully pretty quick. So it is connecting to the live yeah. So if you see here, it queried so these are the logs from the application, right? So I used the search term cat dog, right? So that's what it shows here. If I were to use something else funky, oh sorry, it's slash funky well, programmer, why not? So let's try that out. Okay, I expected something more funny, but that's fine, right? So in the logs you should see, right? So indeed Slack is actually using this Azure App Service backend right now, which I just configured within a matter of few minutes. Of course, you're going to have something more serious, something more full-blown, bunch of other services, but just goes to show you using infrastructure as code as to how easy it is for you, at least from a dev test perspective, when you're trying to figure things out, building your application iteratively. It's very easy to spin up and destroy your infrastructure and be able to sort of link it with the rest of your infrastructure and components and services. And I also want to show you the fact that it actually, if I were to go into the configurations, right, they were also seeded for us automatically without us having to do anything manual, etc., right? It's taking a little bit of time. So yeah, so all these environment variables which our code is actually using were configured here thanks to our code and Pulumi and all the infrastructure as code magic, right? So that was that. I'm going to also be a good citizen and destroy it. Pulumi destroy is going to immediately destroy the resource group and everything else. So yes, I want to go ahead and destroy it. So yeah, it should start off the process of destroying everything. Yes. Okay, so that's going to happen in its own sweet time. We don't need to wait for it. We can move on to the next demo. All right, so the next one is the ability to use Azure container instances, and the fact that now it is integrated with Docker CLI, and all the magic is going to happen using that integration from your local desktop all the way to Azure container instances, right? So again, I'm going to switch over to my to VS Code and show you this demo. So open an integrated terminal. So what do I have right here? Again, my cheat sheet. I have a very simple, sort of pair of applications. They're producer and consumer applications, written in Go, of course, which are interacting with Redis. Redis on Azure. I've set it up in advance, and one of them is going to produce sort of messages to a list within Redis, and the consumer is going to consume it. Nothing special about it. That's fine. I've containerized these applications. I have them in Docker Hub, but the fact that I'm going to use Docker Compose right now, okay, to deploy them to Azure. So let me show you the Docker Compose file real quick here, right? So this is the Docker Compose file. I'm going to use these images from Docker Hub. They are already there, available. These are the environment variables, which will be changed after this demo. So let me run it locally to begin with, right? So how do we run it? Docker Compose up. That's the way to run Docker Compose applications locally. So let me do that. So right now, It is all running on my laptop, nothing special. It should start the consumer and producer applications and get going. So yeah, nothing, like I said, very simple. One of them is sending messages, the other is receiving those messages, like nothing magical about this, right? Okay, so that's fine. Docker compose down is going to destroy these applications. All right, so far so good. But what if I wanted to deploy these to ACI right now? So there's something called a context creation and logging into Azure. I've already done them. I have created this context as well. I can show you. So essentially, the context is your gateway into Azure, right? So if I were to do, hey, Docker context ls, I have authenticated to Azure and created this context called ACI CTX. You could name it anything. So I'm going to switch to that context right now. So Docker context use, and then the name of the context is going to switch to that context. And now my CLI, the Docker CLI, essentially points to Azure rather than my local Docker engine. Everything I do from now onwards, it's going to act upon ACI. And if something is not supported, it's going to complain, right? So the same thing, Docker compose up, nothing different. The same command, everything is going to be the same. Now it's going to be targeted at ACI, Azure Container Instances. If you notice, it is creating something called a container group within ACI to deploy this pair of instances, this pair of interacting or coordinating applications on ACI. Okay. So if I were to go and check Azure Portal right now, hopefully you should see it. I'll go to home, go to container instances. If I filter by, this, oh, it is still in progress, but hopefully you should see it coming up pretty soon. Let's see. Yeah, ACI Docker, it's here, right? So like I said, this is a container group, right? Bunch of containers can be available within this group. So it is running. And if I were to scroll down here, if you look at this container section, there are two containers running here, consumer and producer. And if I were to show you the logs, you will see the logs for each of these containers here. Okay. But it is not just Portal. This was just to, for you to know and realize that it is indeed working. If I go back to my CLI right now and just check the logs, for example, now everything, like I said, Docker logs is now going to connect to ACI and stream logs from your containers running in the cloud right now. Okay, so if I were to do, hey, show me the logs for my producer container. Okay, so if you see, it's going to refresh, so it's going to send messages like on and on and on. And if I were to say, hey, show me logs from my consumer container right now. So you will notice that, hey, it is, consuming in real time. So, there is a slight backlog here, like you see, consuming, producing, everything happening, so these are simply logs, right, from your applications running in the cloud. Okay. I already showed you the fact that, they are already running in ACI. So pretty cool. Hopefully you found that cool. And like I said, always be a good citizen. So Docker compose down is actually going to, again, talk to ACI right now and destroy all these containers. So very good for dev test environment. You're trying things out, just like in the previous case. You're doing iterative development, very, very clean and simple and convenient way of interacting with the cloud, deploying and destroying containers from the ease and convenience of your local machine, right? You're using Docker CLI, things you're already familiar with. So yeah, all in all, a win-win, at least to me, right? I love this, feature and functionality. Okay, enough of bragging. I think we have a few 5 odd minutes, right? So do we have enough time? I think we do. I can run through this real quick. Mind you, this is a slightly advanced use case. So what I'm going to show you here is the same producer and consumer application, which was working on top of Redis. It is going to be deployed into Kubernetes now, right? I'm going to deploy the same application in Kubernetes, but it is now going to be auto-scaled using two components. One is called KEDA, which stands for Kubernetes-based event-driven auto-scaling. Pretty mouthful, I know. And the other one is called virtual kubelet. It's an open source component which is called virtual nodes within the context of AKS. So I have an AKS cluster which is already activated with KEDA and with virtual nodes, and we'll see what it does. Right, that's the whole point of the demo. So I will, and you can check out everything in this blog post which I've pointed out. I just want to make sure that you understand, you get the context, and you see it working live in the for a real world application. Although it's a demo application, but still, right? This is how you would typically start off and build your event-driven applications, which work on in a serverless fashion in a scale-out manner. So let me dive in here. So the same consumer and producer applications, they don't change at all. The ones which I just showed you locally and on ACI, the only difference is that I'm going to deploy them to Kubernetes. So my cheat sheet is here. I have, like I said, KEDA installed. I have, I have a YAML filed, a secret, Kubernetes secret here, which has the Redis access key available here. It's base 64 encoded. That's all there is. So I've done my homework. That's pretty much it, right? In terms of the initial set of configurations, but the rest of the things I'm going to show you right now. So just to sorry, not nodes, get nodes. So this will confirm to us, hey, so we have a Kubernetes v120.7, but look at the fact that we have a virtual node running, right? So this is built on top of the virtual kubelet project, right? You can read up on it. I'm not going to dive into all the details right now because we don't have enough time for it, right? So we have a physical node and a virtual node here as well, right? And if I were to show you KEDA, so I'm just looking up all these CRDs. CRDs are nothing but custom resource definitions within Kubernetes, and KEDA is one of them, right? So if you see, there are some of the KEDA components which are already installed here in my cluster. Okay, so that's that. I'm going to start off and start deploying the components one by one. Okay, so I'll make sure that my secret or all the credentials are there within Kubernetes and my consumer deployment here, right? So I'm going to deploy this consumer application within Kubernetes. Let me show you this YAML real quick. So this is nothing special, just a deployment, good old Kubernetes deployment, nothing special. It points to this particular Docker image of mine, the same thing which I showed you earlier, uses a bunch of environment variables. That's all, nothing special, right? Good old Kubernetes deployment. So hopefully it should have started by now. And you will see the fact that now it is being created within Kubernetes, right? We are getting pods here. We're searching for pods, right? But the beauty right now here is the fact that this pod is not running in that virtual machine which AKS has allocated for us. It is actually running within ACI or Azure Container Instances. And that is thanks to the virtual kubelet project or virtual nodes within AKS. Now, how is it working? I should have shown this to you earlier. Thanks to this node selector, right? So this selector, which we have already configured here. So it says, hey, for this deployment, if this node selector is present, and if it's of the type virtual kubelet, please deploy it to the existing provider. Right now, it is ACI or Azure Container Instances. So let me show you this container running in ACI. If I were to head over to my Azure Portal container instances, so hopefully you should see it, right? So this one right here. So this container is running right now, okay? So this is the magic of the virtual nodes. Now let me bring in KEDA as well, right? Now, if I were to quickly show you the logs, just to, CTL logs, so it works, right? So yeah, it is working right now because there is a producer application, which is running in the background, or it sent a bunch of services there. Okay. Now, if I were to deploy KEDA, I'm going to deploy something called a scaled object. Now, before I do that, let me show you what the scaled object is all about. Now, the magic of the scaled object is, what it tells you is this: hey, I am going to point at this deployment and make sure that it auto scales based on a criteria. Now, this criteria is defined by trigger. Now, my trigger here is a Redis list. Okay. Now there's a list called events, and if it has a length of more than 10, I'm going to scale my deployment to a maximum of 10 replicas here. Okay, so in a gist, this is what the scaled object will do once I deploy it, right? So I'm going to deploy this scaled object right now. Show you something. Scaled object created. Now, just to make sure that it was deployed. Okay. Now, if I were to go and check my pods now, okay, you see that this is terminating, and probably, yeah, it is still in terminating state. And after some time, you will not even see a pod here. Okay, why is this happening? It is because of the magic, or rather the promise of scale to zero. It is because right now there is no workload for my container to process. All the messages within Redis list have already been processed. Now, basically, the length of my Redis list right now is 0. So I don't need to have any workload running in order to process anything. So that's the magic of KEDA. Right now, it has scaled down from 1 to 0. Now, if I were to start the producer application again, okay, so you will see that everything is going to come back to life. Right now, let me do that. So this producer application, I think again, nothing magic, just a Go app which is going to continuously produce messages to a list within Redis. So do a run.sh. Oh, okay, let me switch over to my local Docker context first. Use default, because right now it is pointing to ACI. And that's it. If I run this program locally, this is just producing messages to Redis, nothing special at all. Okay. Now let me show you how the auto scaling works live in real time. Okay. Now, if I were to check out or keep a watch on these pods, right, you will see that there are multiple pods which will get created slowly, right? So it is increasing from 1 to 2 all the way. So the max limit for us is 10, right? So we have the 2 pods which have spun up right now. By pods in this case, I mean right now it is running on ACI. So essentially they are ACI containers. So if I were to hop back into my Azure portal right now and refresh this, because I have a query here, if I were, let me enter this again and see if it's refreshed. So it is still probably working. So if you see, this is the same name as the pod. If you notice, it has the same name as Z. Yeah, this one, right? The other ones are still getting, they are in a waiting or pending state. They're still getting created, right? If I keep hitting refresh, you should, yeah. So you see, right? Right now there are 4 containers. Okay. So for every 10 messages in my Redis list, KEDA actually auto scales my workload to spin up each container. Now you could change this criteria, of course, it doesn't matter, right? This is how it works right now. So if I were to go back and check something called, the deployment object right here, you should see it getting reflected. So you see right now, there are about 2 containers which are ready out of 6, right? So it's going to ultimately spin up 6 containers, and all of them are working concurrently to process all your messages. So if I were to just show you the logs real quick for something which is running, right? So kubectl logs for this particular pod. So it's going to, the logs, right? So it is, so all of them. So you see the gap here, 48, 51, it's all of these containers are working in tandem. They are collaborating to process each message from the, from the list in Redis. And I can actually show you that list as well. Let me connect to Redis right now. And so I'm connected to my Redis instance on Azure. If I were to do this ln shows you the list of the length of a list. The list name is events. Right now it is 0 because all of them are sort of processing right now, right? So things are, messages are getting sent and produced. So if I run my producer here, also it is already running, right? So, and they are getting processed in real time as well, right? So the list length is essentially 0 because there's nothing there in the list right now, but rest assured they're getting processed, right? So yeah, that's pretty much it in terms of my demo involving Kubernetes and how you can scale out your workloads using KEDA and virtual kubelet. I think I went over by 4 minutes, but yeah, that's pretty much all I have. I think it's a good time to dive into Q&A, and please reach out. If I'm not, if you have questions, concerns, or if you just want to connect, I'm available on Twitter, Medium. Follow some of my work on GitHub. Feel free to connect via LinkedIn. Yeah, so don't be shy. And I'm going to hop over to some of the questions right now. If that's cool. I think I can stop sharing just to make this a little easier. Oh, so a lot of questions here, which is awesome. Yeah, thanks for sending this out. So I see a lot of comments. Is this good scroll up right here? Okay, going live. Okay. Yes, aka.ms az gophers. Yes, the presentation is available here. Really love to see more Go sessions on Azure, some user scenarios or case studies of Go on Azure deploying. Yeah, hopefully you saw some of these, right, Vien? So in terms of app service, I didn't cover virtual machines, but yes, from a context of, hey, can I spin up a virtual machine using say the Azure Go SDK or something like Pulumi or Terraform, right? Even Terraform is ultimately written in Go, right? So you're using Go behind the scenes. So yes, obviously they are all these capabilities, all the Go capabilities can be used in the context of app service, functions, Kubernetes. And like I said, you can package your application in Go containers, run them anywhere. PaaS, containers, Kubernetes, and serverless functions. Is the code available on GitHub? Yes. All the there are separate GitHub repos. There's not one single repo which I have, to be honest with you. So everything is available, like I said, in the slides. There are links within the demo slides. You would see links to either the blog post or the relevant GitHub repo. So everything is available online. Yeah, absolutely, it's there. I don't see any more questions. So, but yeah, feel free to reach out to me on all those channels, Twitter, Medium. Yeah, and if you have feedback, we would love to hear from you. And that's all from me. Over to you, Rashmita.
Thank you, Abhishek, and thank you all for joining us today. Hope you all enjoyed today's session. Please do share your feedback with us. It will help us choose a topic better. Also, if you haven't done the event check-in yet, please feel free to do so. You'll be able to access all the resources. Thank you all once again and enjoy the rest of your evening.